Hi folks, thank you for joining me today. I'm going to be discussing best practices for OAuth and native apps. And by native apps, I mean mobile applications. What we're really going to focus on is how you think about building the login screens or the login experience for a mobile application. We'll also discuss some of the other aspects of this, including accessing third-party and first-party APIs. So we're going to talk about the problem in general. Then we're going to talk about various options you have for solving the login problem. We'll just dive deep into the OAuth flows that might be useful for you as a mobile app developer. And that's really going to focus on your needs as a app developer as opposed to anything that would happen server side around APIs. Then we're going to talk about security and single sign-on. Finally, we'll end up with a short discussion about system browsers and web views. Fusionauth is a customer identity and access management platform. We are a standalone service that you integrate into your application to provide login services. These could include things like adding and removing multi-factor authentication, initial login, registration of customers and users, and more. This stuff is important. It's important to get right, but it's also undifferentiated. It's very similar across different applications. And so by using a tool like Fusionauth, you can get back to building the features that your users actually want to access. I've decided I'm going to light some money on fire. And the way I'm going to do that is I'm going to start a competitive ride share service. I'm going to call it Ubift, and it needs a website. Obviously also needs a mobile app, probably more than one. There's going to be one for riders. There's going to be one for drivers. There may be other applications in there as well. We're going to focus on the application for the riders. So let's take a step back and talk about what problem we're solving. Well, first of all, I'm going to sidestep the really hard problems with starting up a rideshare service. So I'm not going to talk about logistics or recruiting drivers or recruiting riders or raising money to have enough money to compete with Uber or Lyft. I'm going to talk about the auth problems that we're going to solve. So that would be the login experience and also access to other resources. The problems that we're going to look at are user login. How does a user gain access to your mobile application's features and functionality? How does your mobile app, which in the OAuth world is called a client, how does your client access resources outside of the mobile app experience, right? Like, so that would be APIs essentially. And how can you speed development up? Because again, I'm lighting money on fire. I am fighting against two very established companies. So speed to market is really important. And so we will look at solutions in the context of these three problems we're trying to solve. You know, when you're thinking about customer user login, are you talking about one application or are you talking about multiple applications? As I mentioned earlier, in the case of Ubift, you're probably going to have at least two, possibly many more applications. The idea of having one central place where you can control who has access to which applications makes more sense. The more applications you have, the more a central identity store makes sense. When we talk about resource access, as I mentioned earlier, we're typically talking about an API. It's typically going to be a JSON API talking to a service that's running over HTTP/TLS. Who owns these APIs? Is it a first-party API where the company or the organization that controls the mobile app also controls the API? In which case you have a lot more flexibility and control because you own both ends of the conversation. Or is it a third-party API, something like a Google Calendar or Apple's APIs or a third-party currency conversion API or something else where your native app needs to talk to that third-party API but doesn't have a lot of control over what that third-party API expects in terms of authorization, authentication, and even just data structure. Finally, when you think about speed development, one of the things that you can do to get development done faster is to take undifferentiated stuff that's not core to your business, and outsource that to a library, to a third-party service, to a third-party SaaS. In the case of the login problems we talked about, login and registration are both pretty well known and undifferentiated. There is some innovation happening in both these spaces, and definitely in registration, you're going to want to be able to customize things to some extent. But at the end of the day, these are not differentiated features that your users are going to care about. They're going to want to get through them, and you want them to get through them as quickly as possible and as painlessly as possible. There are new things happening in the authentication space, whether that's the widespread rollout of multi-factor authentication to secure user accounts. That's been happening for a decade or so, but it's more and more people want to enable these security features, or it's something that's relatively newer, like WebAuthn or Passkeys, which basically allow you to biometrically authenticate against a website or web application using standardized protocols. All right, so let's talk about some different approaches to solve the login problem. First thing I'm going to talk about is native login. This is something that you may be familiar with. It's definitely a great solution if you only have one application and you need kind of full control of the UX. So this is where you are coding your authentication experience directly in your mobile app and against your APIs or your application on the server side. Your application on the server side is your identity store. We have a client over there on the left that's a mobile device, and then you basically post up credentials up to Ubift.com, which verifies them against the user's data store, and then you get back an access token which you store, and then you present that to APIs if you need to, and you get back the JSON that you expect, and then that's what your mobile app is actually going to display in terms of the available rides that are around for me right now. The benefits of the native login are that you own everything. You own the native application, you own the way that it communicates with APIs and the authentication API. You own the authentication API and the user data store. You can do anything you want with any of that. The downsides are that you own everything. Therefore, you're responsible for everything. And you're responsible not just for initial implementation, but you're responsible for keeping on top of any new authentication options that need to be presented, any new authentication workflows, and any security issues. So let's dig into that a little bit more. Like, what do you own when I say you own everything with native login? All the login flows, and so that's login, registration, add, remove, MFA, add, update, remove profile information, forgot password, user accounts locked, progressive registration, and more. You also need to make sure you secure the credentials. So if you're letting the users log in with the username and password, that password is a high value target. People don't use unique passwords as much as they should. So if someone steals passwords at a site like Ubift.com, chances are high that those passwords might be reused across other accounts elsewhere on the internet. And so you need to make sure that no one can get access to that password. You can do this in the application, right? In terms of picking a secure hashing algorithm that strikes the right balance between time to hash and complexity. You can do this by securing the password value itself. That means selecting the right hash and knowing what tweaks to make to it in terms of the number of times to run it, to balance between avoiding credential stuffing attacks and making sure the user experience is good. You also need to make sure you secure the data store where the password is. So that means locking down your database, making sure that only the correct folks have access to it, making sure that access is audited. You also need to think about designing your API securely. Should you use API keys? Spoiler, probably not, because API keys can be extracted from your mobile app and then used outside of it. What other kind of protection layers are you going to layer in? Are you going to add in threat monitoring that's going to look for anomalous behavior? How are you going to make sure your APIs can verify authentication, can verify authenticated users without necessarily calling back to the identity server, or should they call back to the identity server? So you need to think about all these things. You also need to think about how to work with third-party APIs if you need them. So again, for Ubift, we're going to build some features that depend on calendar integration. So we're going to need access to third-party APIs. As alluded to earlier, stuff happens in the auth world. It doesn't happen crazy fast, but it happens. And so how are you going to keep track of those new developments? Are your product managers going to be on top of it? Is it something that engineering is going to bring to the product managers? How do you determine which of those meet your requirements? And then once you've determined what new features you need to build, how are you going to find the time and the people to build them? You also need to make sure that you understand that you're siloing your user data. And that may be okay. Again, especially if you only have one application, it makes total sense. If you want to have one single view of your user across multiple different applications, that doesn't work so well with this pattern. So let's look at another pattern, one I call native hybrid. You are taking your mobile app, and instead of communicating directly with an application that manages identity, you're talking to an identity store. And Firebase is a good example of this. It's a great third-party one. There are many others out there. We have, again, the same pattern where we're talking to an identity store, we get a token, and we store that, and then we present that to our API, and we get back our right information. Here, we actually have a separate application that is not shown on the screen that is going to be handling other things for us. We also may have multiple different APIs. So the benefits of the native hybrid are you don't own everything, right? Now you're working within Firebase or any other solutions guardrails, but you still own the user experience because you're still kind of connecting directly with APIs. You can leverage the security expertise of the Firebase team to take care of some of the back-end issues that we talked about, right? In terms of the password hashing or even some of the more advanced threat detection that you may want to involve in your authentication system. The downsides are that you don't own everything. So again, you're playing within their rule set. You need to learn their rules. You need to learn their APIs, and then lock-in might be a thing. If you ever want to move away from another identity server, you need to make sure that you can do that. The best time to find out is before you ever put any user data into those systems. So OAuth and OIDC, which are often used together, are another option. So we have native login, where you're coding directly against your application. Then we have native hybrid, where you are using an identity store, but you're still using your user interface directly interact with that user identity store via API. OAuth and OIDC is a different paradigm. So this is more of a standards-based approach. And here we have kind of an external login provider, and that owns part of the user experience. And we'll see what that looks like in a little bit. This generates time-bound credentials, and those are called access tokens. And here you'll see that we're going to reuse the term access token, but here it is fairly well defined the behaviors of this. So when you use this standards-based approach, you actually are getting some of the benefits of people thinking about how to secure APIs over the past decade and what's the best way to do that. That takes away some of your degrees of freedom around designing that API security solution, but it also means that you don't have to think about how to do it. You just do it the way the standards suggest you do it. To kind of expand on OIDC and OAuth and what they are, OpenID Connect, which is what OIDC stands for, is an authentication layer built on top of OAuth. OAuth stands for Open Authorization, and OAuth is really authorization without the knowledge of the identity. So an example of that is a car key. A car key gives you access to the resource of being able to turn on a car and drive it away, but the key doesn't have any idea who you are. So if I have the key, I can get in my car. If my neighbor has my key because I give it to them, they can get into my car. If someone finds the key lying around because I've lost it and they know where the car is, they can get into the car and drive off, even though I don't have any idea who they are. That's a good way to think about OAuth. Is it basically is a way to get you a set of car keys that you can present to resources which correspond to cars, and the resources don't have to have any idea who you are. OIDC, on the other hand, is authentication, and it's often paired with OAuth. Authorization, the car keys are not part of OIDC at all. you often get an access token at the same time. It's not part of OIDC. One way to think about it, OIDC, or authentication without authorization, is it's like an ID card that doesn't give you access to anything. It just says who you are, so that then you can later present it to other things, or even use it to just remind yourself of who you are. And that's where the OIDC process is helpful. It's about authentication. It's about knowing who someone is and when they authenticated, as opposed to what they can do, which is OAuth. In all of these scenarios, we're going to use the Authorization Code Grant. That is basically the recommended OAuth grant for anything that involves a end user. The standards-based approach has trade-offs, as well as the native and the native hybrid approach do. The benefits are that you get to leverage this Auth server and get all the functionality that is included in it. And that could include a lot of those workflows that we talked about, the login flows that you're going to have to implement yourself. You also have security, and because of the flexibility of the OAuth server approach, you can actually have more control and more security over your users' data than you do with the native hybrid approach, because you can actually bring that in-house and own the database and the servers that that's running on. Or you can choose to continue to use a third-party Auth server as well. The costs, as you may guess, are you have less control, right? There's more guardrails, there's more rules, there's more APIs you need to be familiar with, but you get more functionality and security in exchange for that. I do want to talk about the elephant in the room. If you're a mobile app dev, you probably care a lot about how things look. So you want to make sure that your mobile login page is pixel perfect, and that's really important to you. You want to make sure that as a mobile app dev, if you choose to go with the OAuth and OIDC route, you explain your trade-offs and you explain the speed to market and the increased security and the increased functionality that I'm going to show you as a trade-off for less control over the user interface. How many of you all noticed that there was actually a small difference in the previous two slides? So we have this one and we have this one, and they're off by 1 pixel each way. And I think that's the kind of thing, if you notice that and it frustrated you, then congratulations. You can get a free t-shirt by going to Fusionauth.io and downloading it. And if it didn't frustrate you, then congratulations. You're much closer to the way that I think. And you can also get a free t-shirt by going to Fusionauth and downloading it and sending us a screenshot. The important thing to know is that the OAuth approach gives you additional security and functionality, and the trade-off is that you don't control the UX as closely. The website is visible, and native look and feel, especially across different platforms, is more difficult to deliver. So here's an example of a Android app that is one of our clients. So on the left is the native app, and then on the right is the login experience. So you can see that there are white bars across the top and the bottom. The bottom is just because I use Firefox on Android. I think it would be up at the top if it was on iOS or on a Android device where someone used the Chrome browser. But regardless, you're going to have something that shows that this is a website, and it's going to show it's a website for good reason. If you wanted a full screen app, if you wanted the login page, which is in the web browser, to be full screen, it's technically possible on Android, but iOS doesn't allow it. And I think that it's worthwhile to note that there are good reasons, as I alluded to a second or two ago, why you would want to continue to let the user know that they are entering their credentials into a website and not into your native app. People understand the browser security model, they understand domains, and they understand the lock icon. And so when they go to your website and see it says, ubift.com, they're going to have trust that they're entering their credentials into a website that's controlled by you. This is from an RFC that's a best practices for native apps document. And the important part is what's in orange. I'm not going to read the whole thing to you, but basically, as part of our responsibility as developers, we want to make sure we encourage users as best we can to do secure practices. And entering your username and password willy-nilly into any application that exists on a mobile device is not a good practice to encourage. So we want them to see the domain and say, oh, that's ubift.com, as opposed to being something else that is fishier. It's also discussed pretty regularly. AppAuth, which is a library that helps with authentication on mobile devices. They've discussed this a few times, and they keep coming back to the answer of, hey, we're going to follow the RFC. We're not going to hide the URL bar or make this look like part of your application. You can make it look like your application, but it's not going to look exactly like your application. So these are choices that you need to have a discussion with whenever you're considering building your mobile app and using OAuth and OIDC for your login process. Let's talk about the Ubift identity architecture, and we're going to focus on OAuth and OIDC. Again, those other two options that I mentioned at the beginning, native login and native hybrid, they're great options that have their own set of trade-offs. I'm going to focus on OAuth and OIDC because that's what this talk is about. We have our client over there on the left, and then we have our identity server, which is going to handle all of our user authentication needs. And then we have rides.ubift.com, which is an API. The first thing we need to do is register the client. And what we're doing is we're basically taking this application, which is not the actual real running code. It's like this instance of the application. So the rider application is one instance of an application, and we're going to have to tell the identity server, id.ubift.com, about it. If there was a driver application, if there was a customer service application, we would each register them up with the id.ubift.com identity server. Once we've done the registration, we can walk through some of these different scenarios. So we're going to talk about login, then we're talking about first-party access, then we're going to talk about third-party access to APIs. So let's talk about login first. The way that it's going to go down is the mobile app is going to request a web page, and it's going to pass in the client ID, which is the identifier that was given to it when it was first registered, right, in that registration step before, and then some other information. This is an example of the URL you might request to start the OAuth/OIDC login process. It's a lot, so let's kind of step through each piece. So first, we should always be communicating over HTTPS, over TLS, unless you're in development. You want to have your own hostname, and that is going to give you a lot of flexibility if you ever want to move off of this identity server in the future. If you control the endpoint where all of your native apps that are out there in the wild communicate to, then you can put a proxy in, you can do some other things. If you let that be owned by your identity server provider, right, like an Auth0, then you're going to have limited options if you ever want to migrate. Then we have the path to the authorized page, and this is totally non-standard, but it usually ends in authorize. Then we have the client identifier, and this right here, it's a UUID, but it could be anything, a string, an int, as long as it uniquely identifies the client to the identity server, right? And so again, the client in this case is the rider app, not necessarily each app that is installed on 10 or 20 or a million different users' phones. Those are all the same. They'll probably have the same client ID. Then we have our response type, and this is basically saying we're going through the Authorization Code Grant that's specified by the specification. Then we have our redirect URI. So if this were a web application, then that would point to a public URL. And this is basically the redirect URI is where the authentication server, the identity server, sends the user after they've been properly authenticated. And at that point, the application, that code that lives at that endpoint, needs to do something to kind of complete the process. But for a mobile app, that's going to be a deep link URL into your application. We have a scope here, and the scope basically says, hey, we want to do OpenID as well as the normal OAuth Authorization Code Grant. And finally, we have a state parameter, and the state parameter is used in a couple of different ways. It can be used for security purposes. It can also be used to deep link into a certain state of your application. So you could imagine the Ubift app might let you look at how many rides are available close to you before they ever make you log in or sign up. It might let you get pretty deep in the process of selecting a ride before they ever require you to sign up and add your credentials and add your credit card. But after you've done that, after you've signed up, if you're already deep in the app, you probably will want to be delivered back to that same state, right? Looking at a particular driver or a ride. So that's what the state parameter is good for, because it's going to be passed from the native app to the identity server and then available after the user is authenticated again. You can have that be a URL safe JSON encoded string or whatever you need to do to get that state back out of the string and turn it into something that your application can provide. After we've gotten that page, which has a request for username and password, or maybe there's some other authentication mechanism there, we don't really care. And that's one of the benefits of OAuth and OIDC, is that there can be other authentication mechanisms built into that page, and we as the app dev don't really have to code them or build them. But in this case, it's a username and password, so we're going to post the username and password credentials and then all those other things that were part of the authorized request. The identity server is going to authenticate the user, and again, we don't care how that happens, whether there's additional checks or checks for impossible travel or MFA required or whatever. It's going to take care of that. Then it's going to give a 302 redirect with an authorization code to that endpoint, to that redirect URI endpoint that we talked about. And the authorization code is just kind of a one-time string that indicates that this was an authentication event that happened. We're going to call that redirect URI callback, right, where that code exists, and that code is going to catch the authorization code, and it's also going to have information about the client ID. This is an example of that redirect URI. Then it's going to, that code that lives at that endpoint is going to post up to the identity server with the auth code and some other parameters, and it's going to get back a couple of tokens. And because we asked for the scope of OpenID, we're getting back an ID token, which is an artifact of OIDC. We'll talk about that a little bit later. And we're also going to get back an access token because this was the Authorization Code Grant, which is an OAuth grant. As mobile app developers, are going to store those off in a safe place. What safe means, we'll talk about. So that was a lot. That was a lot to go through, right? That was probably 10 steps, a lot of dancing back and forth, 3 or 4 parties. And at the end of the day, we just end up with these tokens. The nice thing is that there is a tool out there, a library that you can bring into your application. Called appauth.io, and it supports that flow. It's got support for iOS and Android and React Native and Flutter. They provide example applications. They follow best practices, and it's maintained. It's maintained actually by the people behind OIDC. So I would highly recommend using that rather than coding any of this yourself. But there's one fly in the ointment, or one issue that I did want to kind of dig into deeper. And it's related to the question of who can register deep links on your device. And the answer is that with a deep link like this, anyone can, right? And that can include you, who are a valid application developer, or somebody with bad intent in mind. And so that leads to the next iteration of OAuth for login. And it uses something called PKCE. And PKCE is designed to stop bad folks from accessing aspects of the OAuth flow that we just went through. And it's not pronounced PKCE, it's pronounced PKCE, just FYI. I'm going to talk through PKCE conceptually. If we have a bad actor on the left, we have a normal person or app in the middle, identified by the white stick figure, and then we have an identity server. The problem PKCE solves is we want a way to have this entity be able to interact with this entity 2 or more times without the bad guy being able to pretend to be this normal person. So we can do this by having the normal entity, the stick figure, generate a random string. So let's call it this conf is awesome, right? This is a horrible one. You should really make it long and totally random and high entropy. We're going to take that string and we're going to put it into an envelope. And then we're going to hand that envelope to the identity server. And the identity server is going to store that off. We also need to save that off ourselves so that we can do stuff with it later, but we're going to keep it secret ourselves. Time passes, and then we want to have a second interaction with this identity server. And remember, we want to make sure that the identity server knows who we are and knows that we're the same party that started that first transaction. So what we do is we pass up the unenveloped string. So we pass that up along with whatever else we need to do to say, hey, this is us. And then the identity server can open up that envelope and see that the string that was passed in the first interaction is the same as the string that was passed in the second interaction. And so assuming we're able to keep that secret safe as stick figure, we know that that is the same entity. So then we can pass back whatever message value we need to pass back. So if there's an attacker in the mix, we still do the same random string generation. We put in the envelope. We send the envelope to the identity server. So the hacker moves in. Now the hacker wants to send a second message to the identity server as if it were the legitimate user, the legitimate stick figure. And the hacker might do that if we're away from the conceptual PKCE and we're talking about the native app. The hacker might do that by registering a second callback that is the same as the callback that the normal app registered. So time passes, and now the hacker wants to send a message up to the identity server as if it were the stick figure, but it doesn't matter what it sends. It doesn't have access to that original message, and therefore when the identity server opens up the envelope, whatever string it gets passed, it won't match, and therefore it won't send back any data. That is PKCE conceptually. So let's dig into actually what PKCE looks like with some diagrams. So again, this is very similar. We're going to call that get, and we're going to pass up some additional parameters when we post the credentials. We're going to pass up a code challenge and a code challenge method. This is what those look like. The code challenge method, the value you want to use is S256, which basically says I'm going to hash this value, this random string, with SHA-256. You can do it other ways, but this is the most secure way and the most widely supported way. And then the code challenge is the random string that is in the envelope. In this case, the envelope is SHA-256 hash, but it's not the secret itself, it's the hashed secret. So it's the hidden secret. Then we go ahead and get this code again. This is very similar to what we did before. We're getting the redirect back to this deep link. And then when we actually call up to get our tokens, we're passing in the code verifier value. And that code verifier value is the actual first random string, right? The string that we previously had hashed and sent up. So now id.ubift.com can validate these two strings. It can hash the second string it receives and see if that value is the same as the first string it received. And if that is true, then it knows that both requests came from the same application. Because we can't open an envelope in the same way, when we use a SHA-256 hash, we go the other way around, which is basically we hash the unhashed value and see whether that is equal to the hash value we received first. So this is similar to this step of the PKCE conceptually flow. Once the identity server verifies they know who they're talking to, then we get back those ID and access tokens and store them off. The nice thing is that OAuth helps here as well. At the end of the day, how do we know the user is actually logged in? Well, it's these tokens that tell us that. Tokens are cryptographically signed by id.ubift.com typically, and they're URL safe. So they can be sent in a header, they can be sent in a form parameter, they can be sent as a cookie. Here's an example of a token, and the token actually has a payload. The payload is just a JSON object. So this is an example of what you could put into a token. There are two main kinds of tokens that we've seen so far. There's the ID token, which is a product of OIDC, and this is the ID card, right? This is the authentication without authorization. You can read it in your application. It's time bound. The client is what should look at the ID token. There's also an access token, and this is a product of OAuth and the OAuth specification. And this is something that your application should store, but shouldn't look at. Your app is going to provide this to APIs to get access to data and functionality. Again, it's also time bound. So rise.ubift.com or any other APIs are the things that the access token would be presented to. Now that you have the ID token and the access token, you need to validate the ID token. And there are two parts of this. You need to check the signature, and then you need to examine the claims. And claims are just a fancy word for the values in the payload. Here's some Swift code that I've kind of highlighted important parts of. We're going to download some public keys so that we can validate the signature of this token, because the tokens are typically signed by a private key on the ID server and then verified by a public key on the client. Right where it's orange, we're actually going to pull down the public keys. The second to last line where it says try signers.verify, we're actually going to call library, and that's going to be what verifies the signature, and it loads it into a structure. This is the important bit, right? We've gotten the verifier and we've passed in the public keys, and now we're passing in the token, and we're going to load it into a structure. Here's what the structure looks like. In this case, we have a couple of different claims. The subject is an identifier for the end user, and this is something that should be immutable over time, so that, for instance, if you're creating a little database of the user's preferences or something like that, and you need a key into that table because you had, support for different kinds of users on the same mobile app, you could do that. Use this as the key. You have the expiration claim, which is how long it's going to be until this token is no longer valid. And then we have like a string, which is like their name, and we could use that to display their name. One thing that's worth noting is that you definitely want to use a library to verify that signature and to get those claims out. And AppAuth.io is not going to help here. There are others out there. One thing you want to be aware of is that you want to make sure that you're getting a library that actually does verification of signatures. There are some libraries out there that just do decoding of the token. And when you decode a token, all you're doing is basically base 64 decoding it. You're not actually verifying the signature, which means that anybody could try to create an ID token and inject it into your application, basically masquerade as somebody else. So once those steps have been followed, you've validated the signature, you've examined the claims to make sure they're kind of what you expect, the user has been logged in. So you can be sure of that. Yay! Now you can build the user experience based on the values of the ID token. So again, here's the claims. And I kind of already mentioned you could use the name to show the person's name up in the menu bar. Should you use the ID token for authorization? And what do I mean by that? I mean, you could have a roles claim in the ID token, and that role could have something like the string admin, and you could choose to show admin functionality, right? Like maybe there's a separate screen in your Ubift app that lets you get a ride for free if you're an admin or something like that. Should you show or deny that based on the roles in the ID token? Well, it's not designed for it. It is a signed value that's been generated by the identity server, the authorization server. So you can use it. And the way I would think about it is I think about it as part of a defense in depth strategy. The same way as if there's a web application, you can never trust the JavaScript to be 100% bulletproof. Someone can always modify it. Someone could modify your native application, but you could definitely use it to present or hide user interface elements. But you also should check on the server side. So you shouldn't have the ID token be the sole source of authorization decisions. When the ID token expires, you basically want to re-authenticate. So let's talk about first-party resource access. So this is going to be a lot of the same dance that we saw previously. So I'm going to skip over some of the pieces. So again, you're going to request that HTML page. If you only care about first-party access and you don't care about that authentication event, then you can get rid of the scope of OpenID. That's totally legitimate to do. After that page is requested, you're going to go through that whole redirect dance and get the tokens. I'm going to skip right to getting the access token here. And again, we don't have the ID token because we removed that scope. Now we can present that access token to the Ubift.com rides API, and the token should be presented like per the documentation of the API. So again, if you are talking about first-party API, you can go talk to the developers, hopefully, and say, hey, where do you want this token? It's often in the header or it's in the cookie. Sometimes it's in the authorization header. It could be in its own header. Doesn't really matter to you. You just need to find out what it is. Then the rides.ubift.com API needs to validate that token, that access token. The same way the client had to validate the ID token, the API should validate the access token. I'm not going to dig into this too much. I have other videos that talk about what that validation step looks like. So just trust that your API developers are going to validate that correctly. And then you get back the JSON. And again, this is JSON that you can represent in your application however you see fit. When the access token expires, at the after validation, you're going to get back a 401 or maybe some other status code depending on how your API developers build it. But there'll be some kind of message that says, hey, I can't give you the data you asked for. You could force the user to re-authenticate to get a fresh access token, but a better answer is to use something called a refresh token. So the way you get a refresh token is you add a different scope. You add a scope of what's called offline access, and you do the same dance. Again, we're getting that HTML page, we're passing our credentials, we're doing the redirect, we're exchanging things for a token. We get back what's called a refresh token, or here it's an RT. It's the orange token. Per specification, totally a random string, doesn't have any internal structure, only has meaning for the identity server. So now when an access token expires, it looks a little more like this. So again, we get the 401, but we can catch that, and now we can send that refresh token back up to the identity server. The identity server can then determine that a new access token can be granted and can pass that access token back to your mobile app, and then your mobile app can pass that access token back to the API, and the API will revalidate it and determine it is a valid access token because it's new and it hasn't expired, and then it's going to pass the right info back. Again, appauth.io is not going to help you with kind of the refresh token dance. It's going to give you the refresh token when you go through that initial authentication event, but it's not going to take care of automatically refreshing tokens for you. So third-party API access is a slightly different animal. We're going to add a feature that if I put the words trip in front of any calendar event, and I've connected my calendar to my Ubift app, and I put an address down, then Ubift is going to take care of calling a ride for me at the right time. It will know where I am, it will know how long it will take for me to get there, it will allow a buffer time, and I can be magically notified that I didn't have to schedule a trip to the dentist. This trip to the dentist was scheduled for me. Well, to do this, we need to have access to the user's calendar. Easiest way to do that is to have an authorize button in the application. This is what an authorize screen looks like for another kind of application. I think this is buffer, but it doesn't really matter what it is. Basically, you're going to build a screen that says, hey, connect to Google Calendar. And then we have now two additional components in our application architecture. We have the Google Identity Service, which is the big G, and then we have a calendar, which is the API that we're going to want to call. Again, to get access to third-party APIs, we need to register the client. So we're going to, take a representation of this native app and put it into the Google Identity Server, and then we do the same dance, right? So we make it the authorization request, we get back HTML, we post some parameters including the username and password. So we get back some HTML, we're going to post some stuff, Google's going to authenticate the end user, and then we get back the authorization code, and then we can call into a token endpoint and get some tokens. And In this case, we're getting a refresh token and an access token, and then we're going to present the access token to the calendar API and get back calendar JSON. There's nothing to say that you can't have this work across multiple different APIs, right? Including first-party and third-party APIs. So we might get the calendar JSON first, and then later get the rides JSON. And we've previously gotten both different kinds of access tokens. So what we've seen here is basically how to do login, which is getting the ID token and validating it. Then we've talked about first-party and third-party API access and what those look like, and getting the access token. And for first-party, we saw how to do the refresh grant as well. That is similar with the third-party API access, as long as you request the same scope. So let's talk about security. So tokens are time-bound limited credentials, and they're held by your native application. They are just like keys to a car, so you want to make sure that you take care of them. You don't leave them lying around for other people to pick up, because anyone who holds a token can present themselves to the APIs as if they were you. Another way to put that is possession grants access to the resource. So take care of your tokens the same way you take care of your car keys. So the threat vector here is if we have somebody who somehow gets access to our mobile device and they are looking through public storage that hasn't been sandboxed per application, and they somehow get the access token and they can send it off to an external system, then that external system can present that token to the API, and the API will respond back with the data. The other thing you need to think about is not just keeping your token secure in storage on the device, but they also need to be secure in transit. So it means use TLS. Don't put anything in the URL, like in the query string, because those get captured by logs and captured in proxies. Specifically speaking about securing tokens at rest, you want to make sure you put them on the keychain if you're in iOS, or if you're on Android, you want to use encrypted shared preferences. Here's how you could store the token on iOS. This is just some Swift code. You're getting back the access token. This is a result of an app auth call. And then you're calling save, which is just a function that you've written. Then you're saving it off after you associate it with a certain API endpoint. Then you can read the token back later when you need it. And then you can actually present the token to a given API endpoint. Here we're adding it as a bearer token in the HTTP header. Looking at the token storage code, important things here are that we're storing it as a generic password, and we're using sec_itomadd, which is storing something on the keychain. To read the token, we're basically pulling it off of the keychain. Again, we have the indicator of the service that it is associated with, so that you can, again, put multiple different tokens onto the keychain. Let's talk about single sign-on. The idea of single sign-on is that instead of logging in with an identity server that you control, you log in with Google or Apple directly. So we don't use this identity server, we replace it with Google or Apple, what have you. It tends to follow the OAuth and OIDC flow. You get back tokens in the same way you would if you use your own identity server. You actually can combine the two and offer via the identity server. If you do that, you basically have like this facade layer, which introduces additional complexity, but does offer future proofing, so that the identity server can be responsible for dealing with Google and Apple and any other identity provider that you want to offer. You just interact with the identity server. So the way that would work would be, you basically configure the identity server to interact with Google, and then the user goes to the identity server first and then perhaps on to Google if they choose to. The nice thing about using single sign-on is there's lower friction, right? The accounts already exist. If you're using an iOS device, you have an Apple account. If you're using an Android device, chances are high you have a Google account. So you might not need registration at all. One issue is that you are locked to that service and you only get what they choose to give you. And that's a combination of what Google or Apple choose to give you plus what the user chooses to give you. An example of that is that Apple only gives you like the first name, last name on the first authentication. If you do follow-on authentications, you don't get that information. There are additional rules around single sign-on. So if you offer social sign-on like Facebook or Google or whatever, and you're on an iOS device, you also need to, per rules of the App Store, offer sign-in with Apple. So that's kind of Apple muscling in and making sure that their identity provider is a first-class citizen in this world. Let's talk about the system browser versus the Webview. So the short answer is don't use a Webview. The only reason why you might is if you never call out to any third-party services, you want kind of absolute control and you own your app end-to-end. If you use the system browser instead, the system browser is Safari on iOS and then Android Chrome, pretty much on Android, unless the user is someone weird like me who installs a separate browser like Firefox or Brave or Opera or whatever else you want to do. So the nice thing about using the system browser is that cookies are shared. So think again, if you have multiple different applications, right? We have a rider application and a driver application and a feedback application or a Ubift Eats application. And if we use a system browser and someone logs into the rider application and then they go to an identity server and they log in and then they come back and they're authenticated into the rider app, and then 20 minutes later they get home and they open up the Ubift's Eat app and they log in. After they click on the link to say log me into Ubift Eats, it'll take them to that same identity server, which will probably have cookies and will recognize the user and they will be authenticated, and then it will come back to the Ubift's app without them ever having to enter their credentials that second time. So you basically get a single sign-on between different applications if you have multiple applications and you use the system browser. Another virtue of using the system browser versus a Webview is, as of 2021, you can't actually access Google's services via a Webview. The reason for that is that Google doesn't trust the security of the Webview. So they don't trust you as the application developer to not be watching what the user types in the Webview. And frankly, Instagram, I think, did that a number of years ago where they were kind of monitoring all the things you were doing in a Webview. Google basically said, hey, as a security protocol, we're not going to let app devs access Google services if we can determine that they've started the Authorization Code Grant in a Webview. You also get strong encouragement to use the system browser from Apple as well. When they introduced their second generation system browser, they said, when you use the system browser, you're basically letting the user leverage all the security and privacy features of Safari, as opposed to a Webview where they don't have those. Which system browser you use depends on which platform you're on. If you are on iOS 12 or later, then you want to use what's called the AS Web Authentication Session. As I mentioned in Google, you can use either the system browser or what's called Android Custom Tabs, which is like custom Chrome. AS Web Authentication Session has been around since 2018, and Android Custom Tabs has been around since 2020. We talked about login options, we talked about different OAuth flows, we talked about security, we talked about single sign-on briefly, and then system browsers and web views. Additional resources, here's a link to appauth.io, that library that helps you with so much of the initial Authorization Code Grant. If you're interested in learning more about the different cookie rules around the system browser on iOS, this is a good resource, and this is an example of how to store tokens in the iOS keychain.